Okay guys, we're going to go ahead and get started. So the first thing that we're going to do is, hold on, we're going to do a couple things first. So announcements. Homework 4 is due next week. It's going to be due at midnight on Tuesday, so same thing as usual. Let's see what else. Okay, so another thing, office hours. So we added Monday office hours, if you guys have email or saw it on Piazza. So they're in the same location at the same time. They're just different days. So that probably will help some of you out who start the homework on Monday or like have last minute questions. You can go ahead and come to office hours on Monday. And also this week, if you want to come in, we can help you do like a little midterm review. So if you're worried about the midterm, we can help you get some of your questions answered. And okay, so again, the midterm sign-up links. If you can go right now, go to this link and sign up. So I think most of you are signed up, but the problem is you're not evenly distributed. So we have a lot of spots with no staff and a bunch of you signed up. So if you have the time in your schedule to like move to a different time, please do that because otherwise it's going to create some logistical problems. So if you can go ahead and do that. Just take like 2 minutes now and do that. Okay, if you guys are done with that, then we can go ahead. So with midterms, you'll get your room assignment soon, so just keep an eye out for that in your inbox. We'll email all of you. We'll probably put out a spreadsheet too that's like a list of like student net IDs and room numbers, so make sure you stay posted for that so you know where you're going to go. Okay, so now we're going to do a sample midterm question. So this is going to be an example of like the type of thing that you're going to get, how it would work in an interview, and like what kind of things we expect from you. So that's going to include things like, obviously, you know, getting close to the right answer, getting the right answer, and most importantly, explaining what you're doing. So in CS interviews, sometimes even if you don't get the right answer, if you explain what you're doing and they know you're like have sound logical reasoning and you're good at expressing your ideas, they'll give you a chance anyway because they know that you're pretty smart. So you always have to explain what you're doing. So we're going to go ahead and do that now. We have a staff volunteer. So I'm just going to like, okay, so just this. So, yeah, hold on a second. I'm gonna be the pretend interviewer. Okay, so this is the question. Ready? Given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So that's an example of like a question we would give you guys. Okay, go ahead.
So what I'm going to do is first I'm going to do given an array here. So first what I'm going to do is I'm just going to create a dictionary where I'm just going to store how many of each number that I'm going to have in the array. So call it count. Then I'm just going to, what I'm going to do is I'm going to loop through all the numbers in the array. Right, and if that number is already in the dictionary, then I'm just going to increment it. Otherwise, I'm just going to add it to the dictionary. So, so now I have a dictionary which has the count of, or which basically has each number in the array and how many times it occurs in the array. So now what I'm going to do is I'm going to loop through all the numbers in the array again. So now that I get to, so now when I'm at a specific index here, I'm going to calculate what the complement of that number is for whatever the value is that I want to achieve. So, sorry, let's add that as a parameter here. So now what I have is I have another number that I'm going to add that I know added with the with that index that I'm currently at in the array will get me this value. So now I want to check if this value is in the dictionary as well, and if it is, then I know that I found a pair then. So if the complement is also in the array, then what I want to find is I want to see if its value is still greater than 0, which in which case I haven't used it for a pair in the past. And if it is, that means I've now found a pair. So I have this number and my original number. So that way I've found a pair now. So I can just say so I want to take that number out so I can't reuse it now because I have the number. And I also want to take out whatever my current number is because I've already used it, and now I have found my pair essentially. And that's basically all you have to do, and you just return the pair at the end. And at the end, you just return the pair that you found, the numbers. And that's basically all you have to do for this problem.
Okay, thank you. So you guys can see he explained each step as he did it. So that was really clear. Like I could tell like what your thinking was at each step, and I could understand the algorithm because you explained it as you went. So that's what you guys should do if you explained it like he did. You get full credit. So yeah, that's basically it. So let's see. So other things you need to know about the midterm. Basically, we'll release this in a student version of the rubric, but you're going to have 3 questions. So one's going to be easy, one's going to be medium, and one's going to be like a challenge, like a difficult question. So they'll be graded accordingly. So the difficult ones aren't weighted super high, but you still get a grade for them. But basically, that's a part of it. So I believe 40% is for correctness, 50% is for communication, so explaining yourself, and then 10% of the grade is for explaining time complexity. So the one thing that he neglected to do, and I didn't actually mention this, is that at the end you should explain how fast this can run. So we talked a little bit about time complexity in earlier lectures. If you're still confused about that, or maybe you're taking another CS class or you took one and you don't understand it yet, if you come to office hours, we can explain it to you, or you can do a quick Google. But basically, you should know how to evaluate the runtime of a function. So if there's 2 loops, you know, like whatever's going on, you should be able to recognize certain features and evaluate or consider those, because some of the solutions might not be the best. So essentially, if you come up with a more efficient solution, you're guaranteed to get more points. We do get points for less efficient solutions, but it really depends on the problem. Okay, so if you have any questions, you can email me or Vivek at these emails, as always, so don't hesitate to do that. And then we're going to go ahead with Python. So Python this week is, hold on just a second. Python this week is object-oriented programming, so you probably have done a bit of this in 125 or other CS classes you've taken. If you work with a language like Java, you've definitely dealt with this before. Okay. Can you guys read that? Is it still a little bit small for those in the back? Anybody? Alright, that looks pretty good. Okay, so if you've done object-oriented programming before, you know that we use it to basically organize data. So if we're doing complex things, so let's say we're writing some sort of database, we work at Amazon, we're writing some sort of database for customers, we want to have like a really neat way of organizing that, of keeping all the information separate and encapsulated, right? So that actually hits on one of the 3 reasons we do object-oriented programming. So basically, it says it right here, but can anybody tell me what are the 3 principles behind object-oriented programming? Some of you already saw it, so that's okay. But we have new candy, so if you want to go ahead and get some, like we just had Butterfingers before, but now we have different candy. So if anybody want to raise your hand, tell me what they think the 3 principles behind object-oriented programming are? Are you raising your hand back there? Yeah.
Like our state and behavior to a form, or is that a different thing?
That's a little bit of a different thing. So the ones that I have are encapsulation, polymorphism, and inheritance. So the first one we're going to talk about, let's see if anyone can get the definition. I kind of talked about it briefly just a second ago, but does anybody know what encapsulation is? Yeah.
Putting information into classes?
Yeah, so we're going to basically, we're going to hide the data, right? So we're not going to, let me show you the definition. So basically, we're going to hide the data and only allow access from certain areas, right? So basically, in Java, this is easy because we have keywords. So you guys use like public, private, and protected. in 125, but in Python it's a bit different. So we don't have these formal keywords. We basically, like, there's some conventions for how to say something is private. So in this example, we have an underscore. So if you want to show that a variable is private, you can go ahead and put an underscore in front of it like this. And so that says to anybody reading it that it's a private variable. Okay. The other thing is, in Java, it works a bit differently, but in Python, if you name two variables the same thing, and they're from different classes, you have to preface the variable name with 2 underscores, and then an underscore in the class name. So that's going to show that you want the variable from that particular class, and so you're not going to confuse that with variables from other classes. And so that's called name mingling. But yeah, basically, that's a version of what you might call private in Java. So this is more protected. This is private. And then this is pretty informative. If you guys want to like really understand this, I recommend reading the documentation. It's pretty straightforward though. It's just that in Python things are a lot less formal. So you have to kind of use these things that might seem like more of a pain, but it's just the way that Python is, and it works. So yeah, so the next one's inheritance. So you guys have definitely done this in 125, but basically subclasses. That's a really important thing. If you want to be super organized, if you want to organize your data, you definitely need to have classes within classes, and we'll take a look at some examples of that later on. And then the last one is polymorphism. So that basically is having multiple functions with the same name. So Python is a little tricky with this, and we'll show you how you can do that, but it doesn't technically allow you to have methods with the same name, but there's workarounds to that, so. Okay, so yeah, so the thing is, Python is what you call object supported, so it's not technically object-oriented, but it has, like, you can use some of those features if you need to, and we definitely are going to, and you have in the past. So all the things that you've been working with so far, so dictionaries and strings and all of those are objects, right? So now we're just going to learn how to create objects of our own. Okay, so here's a nice example. So we've got a class called coffee. We've got a class variable, and then we've got several functions here, right? So does anybody want to give me a little like explanation of what an init does? Exactly, and if you want, you guys haven't been like grabbing candy, but you can if you want. But yeah, also that's basically the right definition. So this is if you've done anything with like C or C++, it's similar to a constructor. So it initializes things. So we've got these member variables here, and so it's going to initialize them to whatever you pass in to that. I want to call it constructor because I have been doing a lot of C++, but whatever you pass in. When you make the object, those are going to get those variables. Okay, and then this here, so it's using this class variable here, and it's incrementing it. So every time you make an object, it's going to increment that. Okay, and so then we have several functions. So you can see this one uses these properties of the object, so name and beans, and then this one prints out the class variable. So this one is different from this one, right? And why is that? What is the difference between these two functions? Like the type of function that they are. Anybody? Yeah.
The bottom one operates on a new instance of the class, the top one only operates on that specific instance.
Yeah, so this is what you call a static method, right? So it basically is only going to act on like, it can only act on like these class variables, right? Okay, so let's go ahead and let's see what happens if we actually play around with this. So, gotta run that first. So we're gonna make an object, and then what do you think this is gonna print when we call drink on it? So drink, this is what drink prints, right? So what are we gonna get? Yeah.
It's going to point I'm drinking a latte made with espresso beans.
Okay, yeah, perfect. So that is indeed what we get. So do you guys understand, so up to this point, does anybody have any questions? So do you understand, like, when we made an instance of this object, we called it my coffee, and we passed in these parameters, right? So they went to this initialization function, and they're passed in here, and then we set them to be what we passed in, right? So these are instance variables, right? So they're like member variables in Java, and basically you're setting them equal to the ones that you passed in. The other thing is, you guys understand what self is? Okay, so self is a reference to the object itself, right? So when you do this in Java, use the keyword this. So basically, it's the same thing as that. So you're referring to the object, and that's how we're like referencing the fact that, like, this distinguishes the fact that we're talking about this one's instance variable, and then we're setting it equal to something, the parameter called name as well. So that can be a little confusing, but you guys have probably done this in another language, definitely in Java, where you set, like, you can name the parameter the same thing as the instance variable, but we have to distinguish here. Makes it a little bit less confusing. Okay, and then let's go ahead and run this. What should this print? So if we go back up here, cups was 0, right? Does anybody remember what we did with cups in it? What do you think this should be? Yeah.
1.
Yep, right, because it incremented it. And so if we go ahead and we do this, let's make one called new coffee. So we have to actually declare it. So we'll just make it have the same properties. And then if I go ahead and call this again, I get 2, right? Does that make sense to everybody? Does everybody understand that? Okay. So that's just because here in init, cups was incremented every time we created an object, and we created 2 objects, so that makes sense. Okay, we have one more example here. So basically, okay, so subclasses are really useful. If you think about, like, what if we have a database? What if we go back to our Amazon example, and we have a customer database, right? What if I want to have a subclass that's like their purchases or something? That could be really useful, right? So it's just more ways to organize data and to encapsulate things. So basically, you can see this one. We pass in the name of its parent class, and then it has a constructor of its own, but there's a little bit of a difference here. So can somebody tell me why you need to do this line? Yeah.
Can you replace it with super?
I'm not 100% sure in Python, but the point, so can you explain more about, like, what is the purpose of the line?
So it creates, or it does all of the initializations that the parent class would do.
Right, because the object that you're making is part of, it's like a child of the, it's in the subclass, right? So the subclass is like a child of the parent class, so we need to include, this object will have all the member variables of the parent class, and then it's going to have its own, right? So this line goes ahead and initializes the coffee class first, the coffee class part of this, and then it's going to do one variable that it has on its own, which is cost, right? So does that make sense? That makes sense generally? Okay. Yeah, and then we have this function here that prints cost, right? So if we do this and we make an object, okay, what's going to happen when we print out drink? Does anybody have any idea what's going to happen? So if you remember, drink was a function from the superclass, right? So what do you think is going to happen when we call it in the subclass? Is it going to work? Yeah.
3.
Hmm?
3.
Let's see. Oh, if you remember, drink was not the, yeah, so drink was the one that printed out the name and the kind of beans. So yeah, that definitely, it worked though, right? That's the important part. Okay, so now this is a function of the subclass, so we run it, we just get your coffee costs this amount, right? Because that was just a function of the, that's a method of the subclass. So that's pretty straightforward. And then what do you think is going to happen when we run this? So this was in the superclass, and it basically, it just printed out the number of objects that we have so far. So do you think it's going to work? What do you think it's going to print out? 2? Probably heard 2 over there. 3? Let's see. Yep, and you're right, because we made 3 objects so far. So we had the 2 original objects that were the from the parent class, and then we had this one object we made that came from the subclass. So that's 3 total. Okay. Okay, so we're going to go ahead and stop there. If you have any questions about this, please come to office hours. The homework is going to ramp up a bit this week, so as it gets a little bit difficult, you guys might need help. It's a lot easier if you come to office hours and just get it done than it is to kind of like struggle on your own if you're having too many questions. So yeah, go ahead and do that or ask on Piazza. But basically, yeah, this is it for this week. Next, we're going to have a lecture on VR. So I'm going to go ahead and introduce Mike. So he's a CA for the VR class here. If you guys have a chance to take it, you definitely should. It's really, really fun. So yeah, he's going to go ahead and give you guys a lecture on that.
Is this loud enough? Yeah. Is it loud? Okay. Is this loud or did it not do anything? Is it good now? Can you hear me back there? Yeah? Alright, I'll believe you. Okay. My name is Mike and I'm going to talk about virtual reality. We're just going to do a super brief overview of a lot of different topics. How long do I have? Alright, we'll keep it. When does this class end? Okay, sure. Yeah, so we're just going to do a super brief overview of a bunch of different things. Yeah, so let's just jump right into it. So we have some super basic math. It's sort of for like high school, Calc 1, Calc 2, whatever. So these are essentially transformation matrices, right? So a big part of virtual reality development is going to be dealing with the mathematical concepts and coding them into different rotation representations. So we don't want to work with traditional homogeneous transformation matrices because then they're missing a bit of data. So then if we hit 2 colliding axes, then it'll end up causing Gibble lock, everything will go all weird. So instead we want to convert them to quaternions, which are the same thing essentially. They describe rotations, but it's in a 4D setting. So we have a little bit of extra information. Instead of orientations, we're dealing with actual rotations. So this should all have been covered in like Calc 1, Calc 2, pretty basic. Does anyone know what this original matrix is doing? No. I'm just kidding, we're not going to talk about this. I just thought it would be really funny. You'll never have to know that in your entire life. Anyway, so let's just go through. We'll start with an about me. We'll talk about the definition of virtual reality. We'll talk about some applications and see some demos from the class last semester. We'll talk a little bit about the hardware, then go into actual virtual reality coding and development, and then just look at some other resources. You can ask questions, whatever. Gucci? Did you listen? Okay. So first we'll do an about me because I feel like that's what you're supposed to do before you give a lecture. So, like I said, I'm Mike. I'm a senior-ish in CS. I've been here for 4 years, but I have another year because I don't do my MPs. I go to lecture. So I was a CA for CS 225 for the past couple of years, and I stopped this semester. And you'll get there and you'll know. I've also done 242 for the past 2 semesters, and then VR for the past 2 semesters, and private tutored before that for VR. I interned at Capital One for the past 2 summers, and then I'm going to be there in Chicago again this summer. And fun fact, Demi Lovato is my favorite thing ever. I'm going to see her this Friday. I paid $600 for the meet and greet, so it's going to be a great time. I have a lot of credit card debt. So first we're going to talk about the definition of VR. So, and we'll get to why it's important, but Steve Lavelle and his wife, Anna Yashova, were professors here. That moving on to bigger and better things, as the University of Illinois, whatever, has some issues, but he wrote the leading textbook, and this is how he defined VR. So a virtual reality experience is anything that induces targeted behavior in some organism by using artificial sensory stimulation while the organism has little or no awareness of the interference. So the main idea here is that it's some kind of experience and some kind of demonstration that induces immersion. So that's the biggest thing about virtual reality, is that it takes some reality and transports you out of that into some other thing, virtual reality. So take a second, we'll just go through, apply this definition, talk to your partner for 2 minutes and go through each thing and talk about it, decide whether each of these things can be considered a virtual reality experience. Go.
I don't feel like that doesn't
All right, is everybody ready? So we're going to go through as a class and you could get some candy apparently. Yeah, okay, so we'll just raise your hand if you thought it was a virtual reality experience. Don't raise your hand if you didn't. So, playing a first-person video game. Who thought this counts as VR? Cool. Who didn't think this counted as VR? That doesn't make any sense. That doesn't, okay. You didn't raise your hand. How come? There's some good arguments to be made. Alright, who else didn't raise their hand? Did you raise your hand? No?
No,
Okay, why not?
because I'm not sure whether it counts as VR.
Why not?
Like maybe some game would count as VR.
That's fair. What does VR mean to you that just a normal first-person video game isn't?
I don't know, because if you're playing like some game on the phone or like computer, it sounds not too real.
Mm-hmm.
If you're playing with some kind of equipment, it sounds pretty real, so that might count as virtual reality.
Sure, that's fair. Why do you disagree with him?
I think there's some level of immersion and it's brought on by like
Censoring.
yeah.
Sure. Yeah, that's fair enough. I won't call on anyone anymore, so you could raise your hands freely. Watching a movie, who thought that it is virtual reality? Sure. Video conferencing, listening to music, playing a third-person video game, reading a book, taking LSD. Cool. Okay. So, the normal like school we teach about VR thing is all of these things are VR, yay. But there's actually an important reason behind that. So we consider there's so many different mediums that are considered virtual reality, right? Because all it is anything that gives you some kind of sense of immersion. So the point of that is that the hardware and the software and the coding and the development isn't nearly as important and nearly as big of the main factor as it is with normal software development. Instead, most of the immersion and most of all that stuff is because of psychology and how the hardware and how the software interacts with you psychologically. So for that reason, virtual reality is a huge basis in your background info in different fields and intersections of different things like medicine and education, because those are all the things, and you'll see this when we go to the applications slide, that will essentially give you that immersion and make it a good virtual reality experience. So now we'll look at some applications and some demos. So here's just 4 random things. If you Google it, you'll get a big old chart of like 80 things that have virtual reality applications. So first one is medicine. So you could do diagnostics, say you get an MRI or an X-ray, then the doctor can have an actual 3D model that they can interact with, which is a lot more helpful than just a black and white picture. You could do some kind of training. You don't have to go into the lab and find some subject or some dead cat or something to practice some operation on. You could do rehabilitation. So for example, people who broke their leg or something and have to go through like building it up by walking, they could just do it in virtual reality instead of trying to actually go and do things in the outside world. It's just a lot more accessible. So an example of this from last semester, hopefully just opens, yay, and hopefully everything works. How do I turn up the volume? Is there going to be volume? Yay, we did it. Okay, so this was a project done with Professor Manuel Hernandez from the kinesiology department. And so the goal is just for physical rehabilitation, paddleboarding in particular, both helps with just normal, movement and precise movements, but also balance, because as you could see the little thing, oh yeah, we should maximize it, true. The little thing down there is balancy. It's a lot of stuff. It was used for his research. Super cool. Yay, you get the idea. So, oh no. Okay, forget you saw that. Then we have virtual tours, which again is big for accessibility. So let's say you have a real estate urban house in virtual reality. Then if you're trying to move to a different state, for example, or you're just disabled, can't really get out of the house that easily, if you can do it virtually, then you have an opportunity you didn't have before to go ahead and look at that house in person. University visits, the same thing applies. You can go ahead and visit a university without actually flying over there. And then museums and other landmarks, say the top of Mount Everest, are also different things that normal people can't typically access. So if you could do that in virtual reality, so again, just giving you that level of opportunity you wouldn't have already had. So this is the Experience Illinois project. I started at the Granger part because I know you all don't like going behind Green Street. So this is just another sponsored project that's, 360, just a little like tour for students to do things. I keep clicking randomly, but it rotates, yay, we could drag it around. Yeah, you get the idea. All of these, there's a link to all of these at the end of the thing. You could go to look at them, it's fun. Gaming is the other one. So there's escape rooms, first-person shooters, hand-based games with Oculus Touch, Vive controllers that, again, add another layer of immersion, both because of the 360 and the looking around and the orientation, but also because when you're using some kind of touch input or touch controller, you're then using your muscles, everything. It's immersive, you get the idea. So what did we do for this one? Oh yeah, here's another game. It was called Saltworks and it used the Oculus Touch. Here's just a video of it. So basically it gives little instructions on the TV and you have to like push all the buttons, pull the lever, it gives you a thing. Super fun, drop it in there, then you get points for doing everything. That's cool, right? Y'all should take the class, it's a good time. But yeah, games. So obviously that's going to be more immersive than like a similar game from not having that. Whatever, and then social media. So I probably should have put, there's just a funny meme here. If you've seen it, then it'll be funny. If you haven't, it'll be whatever. But I should have put like education here or something, especially because we have good examples, and education is a really big component of big application of virtual reality. So don't forget about education. But in terms of social media, there's virtual chat rooms, different multiplayer experiences, which again are just better ways, more immersive ways to access different people and make friends and do things and a better environment than a normal chat room. So there's this one app that's gotten really big called VR Chat, and it's just this big MMO where you walk around with a bunch of friends and just do things. Think like Club Penguin sort of deal, except you're actually there. So there's this video, I think it's really funny. It doesn't matter if you can't hear it. I love that. So that's this meme basically where it's just these things that walk around going, do you not do well or you do not know their way. I think it's really funny, but yeah, that's what VR Chat looks like. There's plenty of other applications. You could see in a different set of project demos, you could Google things. A lot of you have seen different VR things. Cool. So now we're going to talk a little bit about hardware just from a basic level. So you have 3 different components of a VR thing. We'll consider it in this case from the scope of a headset. So we have displays, which are the outputs, sensors, which are all of our inputs, and then the computers, which do the processing. So displays are just anything that simulates some kind of sense organ. So headsets an obvious one with sight, headsets, the screens, you know. Speakers also fall under this thing. They stimulate our hearing. Why can't I think of words? Hearing, yeah. But, yeah. Is there a different word for hearing? Audio or something? I don't know. Yeah, I feel like that's right. Haptic feedback for touch. You could have different smells, different tastes. Sure, and that's all of them, right? Yeah, sensors are things that extract information. They're essentially the input. So think gyroscopes in the headsets. The formal term is IMUs, which is inertial measurement units. If you do any research into VR, take the class, that'll come up a lot. It's essentially a gyroscope. Digital cameras to judge whether or not there's anything in front of you, and also be able to track the positions of things like the Vive controllers or the Oculus Touch controllers. Then normal keyboards, they can take in input if you're playing a game and you use the arrow keys to move, for example. Infrared cameras, anything you could think of that takes in some kind of input and then interacts with the computer. So then the computer is just the device that processes the inputs and outputs, combines everything and does all the stuff. So for example, the computer, the actual PC, if you're using the Oculus headset, smartphone, if you're using like a Gear VR or Google Cardboard, etc. So like we sort of touched on before as far as how VR is different than normal things, you shouldn't assume that the hardware and software is the complete system. And like we said, the person and how they interact psychologically with the hardware is the most important part. Because if you have some kind of like super great experience, it has like the highest perfect resolution, all the tracking's great, it looks super great, but it doesn't have the background information, doesn't have the thing. Think like the kinesiology experiment and project where it could be the most beautiful, like fun thing in the world, but if it wasn't a kinesiology professor that knew how to actually have the effect that it had and make it immersive in that way and make it effective in that way, it wouldn't actually be a good experience. So a lot of virtual reality comes along with ideas and background information instead of just good hardware and straight coding. So now we'll talk about development, which is the cute part. So most VR development, especially if you take the class, will happen in Unity. If you don't know what that is, it's just a game engine. You usually make 3D or 2D games or simulations, whatever with it. It looks like that thing on the right. So essentially it's a lot of dragging and dropping, making pretty things, whatever, not super important. So when you use Unity and want to create a VR experience as opposed to just a normal game, you literally just have to check one box that says enable virtual reality support and you're done. If you use the headset, it'll just take over the camera. So it's super easy if you want to foray into VR. As long as you have a strong enough computer, you could just use Unity like normal and it's all Gucci. All the scripting is going to be done in C#. You could use JavaScript, but it's pretty unsupported at this point. C# is basically just Java. There's nothing different to it. So if you want to take the class or develop in VR on your own time, 125 is good enough background information. And so the difference basically between using Unity and just scripting some kind of game from scratch is that creating objects and setting different properties like speed and weight and gravity and color and whatever you want to do, and will be done inside of the UI through dragging and dropping and different like create a cube sort of deal, instead of actually coding it and having to deal with all the graphics and deal with all the different things. So it's just a much easier workflow for creating games and experiences in particular. As far as coding goes, this is an example of a simple program called FlyUp, and all it does is at each iteration, it'll fly upwards. So there's two components to a default Unity program. So that's the start and the update functions. So start is called right when the object is initialized, usually when the game starts, or if it's a missile or something that you shoot, and once the missile's created, that's when the start function will be called. A lot of the time it's redundant because you could just set variables in the editor like we said, or just at the top over here, just like you're normally programming, but it's chill. So in this case, we have a private variable called speed, which is what we're going to use to determine how quickly we're going to move upwards. Here we just set it to 0.1, just for the heck of it. And then we set the position of our object to a vector 3 at 0, 0, 0. And so all that does, if you look at this transform box over here, is it would set position to 0, 0, 0 in the coordinate system in Unity. So if you use transform.position, it's not super important, it won't make that much sense until you actually use Unity, but it's essentially saying the same thing as like this.transform.position or like self.transform.position if you're using Python. You put each script onto an object, you put the script onto an object and then you just refer to its properties as itself like that. The update function is when most of the actual functionality will come in, so that'll be called every single frame and put whatever in there that you want to happen. So, for example, here we have an if statement that's testing whether our space button is held down. And if that is, we set our speed to 0.3 instead of 0.1. So if you hold down space, you'll essentially go up faster. Then every frame, we take the position and add the speed to it, just at the y coordinate. So just basic physics, like distance equals velocity times time. We're just increasing the thing every frame as time moves on. So it's pretty similar, as you can see, to any normal Java program. It's just we have that start and update function built in, and a lot of the variables are going to be automatically included in the objects in Unity. Does that make sense? Liddy. It's pretty easy. The documentation is really great for Unity if you ever want to play around with it. It'll be like, hey, this is chill. Okay, so here's just some best practices for virtual reality development in particular. And the reason I'm talking about this is so that you just have a better way to think about the bigger picture. Just going back to that idea of the psychological interaction and the immersion is more important than technological specs and the fun, everything like that. So you want to keep your frame rate at least 90 frames per second. In virtual reality, the screen is much, much closer to you, so frames per second drops are much more noticeable. In addition, you're constantly moving and it's tracking and mashing your head motion and your hand motions. So if that's not actually synced up and you're stuttering and jittering when you're moving, that's going to easily cause motion sickness, distortion, and it's just not going to be a pleasant experience. You want to avoid vection, which is defined as illusory self-motion. So think about if you're in a car, you're sitting there and there's a truck next to you, and it starts moving, and you look at it, it looks like you're moving backwards, right? And then once the truck passes, you're like, oh, just kidding, it was the truck. So it's that sort of thing. So if there's a conflict between your optical, as in your vision and what you're seeing, and your vestibular, which is like your balance and your sense of movement cues, then you'll get motion sick. So the ways that'll happen in virtual reality is if you accelerate, you have very fast stops and starts and collisions, things like that, that make your body go like, oh, we're doing something, but really you're sitting still. It gets confused and you'll get motion sick. If you have some kind of 360 video or image that you're using in the demo, you want it to be 4K resolution at the very least. If you have some 360 content, then the resolution is actually going to be shared across the whole entire image or video. So what you're seeing is about 1/5 of the actual resolution. So a 4K video or image is actually just going to look like a 720 pixel, which it's just barely hitting the standard nowadays with technologies and games and movies and everything. Any lower than that, it's going to look really ugly. Color's going to be distorted, it'll be blurry, there'll be a lot of aliasing and sharp edges. Just quality control things that'll really ruin the experience if you don't follow. And then as far as the UI user interface goes, if you lock the user interface to the screen so that it moves with you like a HUD, then it's going to cause some problems. You'll get sick, your body isn't used to things matching, so instead you should incorporate them into the environment. These are just a few examples of the best practices and some things. Hopefully they provide some perspective as to there's more psychological things that are important in virtual reality and interaction and physiological things to pay attention to, but yeah. So some other resources, there's a link to Unity. Did you post this somewhere after? Yeah. So the link to Unity, the textbook, scripting reference. You can check out all the VR projects from last semester. You can email me. Lego can also answer a lot of questions about VR. The best practices guide. And yes, that's all. Does anybody have any questions? Cool. Thanks, guys.
Okay, so one thing before you guys leave, we need to do the attendance quiz. So if you go ahead, go over to Relay and take that really quick before you leave. It will be up in a second, so just hold on. Okay, if you guys are done, you can go ahead and leave. And if you have any questions, you can come up here and ask.